Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to be going over more problems showing examples of how to use conversion factors to help you solve problems like word problems. So let's get into this. So number one, we're told that 1/3 cup of vanilla ice cream provides 141 kilocalories of energy. A typical adult uses about 196 kilocalories per hour of energy while walking. So then the question is, how many minutes would it take to burn off all of the energy from 1/3 cup of the ice cream? So let's figure this out. So the first thing, there's two things you want to do in any word type problem. One, pull out the information, look for the conversion factors. The conversion factors are going to be something per something or some unit related to a different unit. So some relationship, pull that out. You could use that for later in the problem. And then the second thing you want to do is figure out where you're going to begin and where you want to end. And that is 99% of the time in the question itself. So let's look at the problem and see if we can pull out any conversion factors. So it says that 1/3 cup of vanilla ice cream provides 141 kilocalories of energy. So there's a relationship there. So I know that 1/3 cup of the ice cream is equal to 141 kilocalories of energy. So that's going to be important. So we have 1/3 of a cup, and that's going to provide 141 kilocalories of energy. And then it says a typical adult uses about 196 kilocalories per hour. So there we have a relationship of kilocalories per hour. So that's going to be a possible conversion factor that we can use. Okay, so that's about it as far as possible conversion factors. Now, where are we going to begin and where are we going to end? Go to the question. It says, how many minutes? The beginning of the question is the end of your problem. So, how many minutes? We want to know the number of minutes. So that's where we got to get to. But where are we going to start? Let's finish the question. It says, how many minutes would it take to burn off all of the energy from what? 1/3 cup of the ice cream. So we got to start with 1/3 cup of the ice cream. So let us begin. So we have a 1/3 cup of the ice cream. I'll just say IC for ice cream. And then we're going to use our conversion factors to convert from the 1/3 cup of ice cream to minutes. So first thing we need to do is convert 1/3 cup of ice cream to something else. Well, we have a relationship that 1/3 of a cup of vanilla ice cream is equal to 141 kilocalories of energy. So we can use that as a conversion factor and set it up as a ratio. So the 1/3 cup of ice cream, we got cup of ice cream on the top here. We want cup of ice cream on the bottom. So a 1/3 cup of ice cream on the top and 141 kilocalories of energy on the top. So the 1/3 cup of ice cream cancels out and we have 141 kilocalories of energy. Now we can use that kilocalories because we know that 196 kilocalories is equal to 1 hour of time. So we can use that. So we can put 196 kilocalories of the energy goes on the bottom, and 1 hour of time is on top. So now kilocalories cancels out. Okay. And we have an hour, but we don't want an hour. We want minutes. So we're going to convert hour to minutes. So 1 hour goes on the bottom, 60 minutes on top. Hours cancel out. Now we have the minutes. We're done. And all we need to do is multiply and divide. And when we do that, we get 43.2. So 43.2 minutes is the length of time it takes to burn off all of the energy from a third cup of ice cream. And so when we're thinking about our significant figures, remember when you're multiplying and dividing, the rule is that your answer here should have the same number of sig figs as the measurement with the least number of sig figs, ignoring the exact measurements. So 1/3 cup of ice cream, that's not really a measurement. That's just given to us. We have an exact 1/3 cup of ice cream. Here, the 141, that's 3 sig figs. 196 is 3 sig figs. Here we have an exact relationship, so we ignore this. So the least number of decimal places is 3, so we should have 3 sig figs, and so we have 3 sig figs. Okay, let's go to the next problem. Okay, here we have 1 gram of methane gas, CH4, and it's burned, and it gives us 55.5 kilojoules of heat released. Okay, so here we have a relationship. 1 gram of methane gas is equal to 55.5 kilojoules of energy. So that's going to be a conversion factor, or a possible conversion factor we could use. 1 gram of methane equals to 55.5 kilojoules. Okay, so that's really the only information we're given. I don't see any more conversion factors. Now we're at the question. So now we have to figure out where to begin and where to end. The beginning of the question is the end of the problem. How many pounds of methane gas? So you want how many pounds? We want pounds of methane gas. Okay, so that's where we got to get to. We got to get to pounds. What are we going to begin with? Keep reading. How many pounds of methane gas must be burned to release what? 2.170 times 10 to the third kilojoules of heat. So notice that this is not tied to anything. It's not part of a relationship. So this is what we begin with. So you start with 2.170 times 10 to the third. And that's kilojoules over 1. And now all we need to do is use conversion factors to convert until we get to pounds of methane gas. So we need to get rid of kilojoules. We have a relationship. Here we have a relationship between grams of methane gas and kilojoules. So we can use that to convert to grams of methane gas. So let's do that. So since I have kilojoules on the top here, I want kilojoules on the bottom to cancel. So I have 55.5 kilojoules. And on top, I'm going to have 1 gram of methane gas. So 1 gram of CH4. So kilojoules are going to cancel out. And now I have grams, but I don't want grams, I want pounds. So now I got to convert grams to pounds. And so you can use whatever conversion factor that you know. I'm going to use that 453.6 grams of methane gas is equal to 1 pound of methane gas. And so now, let me double check here. Okay, and that is correct. So now that I have the pounds, I'm going to multiply everything on the top, divide by everything on the bottom, and I get my answer. And when I calculate this out, I get 0.0862, 0.0862, and that's pounds of methane gas. And so again, we have to look at our sig figs. And again, when we're multiplying and dividing, our answer should have the same number of sig figs as the least number of sig figs in our measurements. And so here we have 4 sig figs. Here we have 3. And again, here we have 4. And so the least number is 3 sig figs. And so we have 1, 2, 3 sig figs. These zeros are not significant. They're just placeholders. Zeros at the beginning of the number are never significant. And so that is our answer. Number 3, finally, if a person has a glucose level of 101 milligrams per 100 milliliters, this 101 milligrams per 100 milliliters, that is a relationship, that is a possible conversion factor. So let's underline that. Okay, that's the only conversion factor I see. Now the question. So remember, we got to figure out where to begin and where to end. The beginning of the problem is the end. So, or the beginning of the question is the end of the problem. What is the total mass of glucose? So we're looking for the total mass of glucose in grams. We want grams of glucose. In what? Where do we begin? Keep reading. 5.30 liters of blood. That's what we're going to begin with. So we start with 5.30 liters of blood. We're going to put that over 1. And we start converting. So here we have 101 milligrams of the glucose per 100 milliliters of blood. So in order to use that, we need milliliters. So our first conversion is to convert to milliliters. So liters, 1 milliliter, milli is 1/1000th. So 1 milliliter is equal to 1/1000th of a liter, or 10 to the negative 3 liters. Or you could flip it and say that 1 liter is equal to 10 to the third milliliters, or 1,000 milliliters. Either way works. So I'm going to use 10 to the negative 3 liters. That's 1/1000th of a liter is equal to 1 milliliter. Now you could have 1,000 milliliters over 1 liter. That's fine too. It's the same ratio. It means the same thing. Now here we have blood. Okay, so liters of blood are going to cancel out. Now we have milliliters of blood. Now we can use this relationship of 101 milligrams of glucose per 100 milliliters of blood. So now we can put this down. So here on the bottom, we're going to have 100 milliliters of blood. So we're going to put down 100 milliliters of blood. And on top, we're going to have 101, where's my 100? 101 milligrams of glucose. So 101 milligrams of glucose. I'm just going to put GLU for glucose. So milliliters of blood cancels out. Now we have milligrams of glucose. But they want it in grams, not milligrams. So I got to now convert to milligrams. But milligrams, milli is a 1/1000th again, right? So 1 milligram is going to be equal to 1/1000th, or 10 to the negative 3 grams. So I can use that. Or you could say 1 gram is equal to 1,000 milligrams, or 10 to the 3 milligrams. So either either conversion factor works. It's the exact same ratio. So now I'm going to go ahead and say 1 milligram. I'm going to put 1 milligram on the bottom, 1 milligram of glucose on the bottom, and that's going to be 10 to the negative 3 grams of glucose on top. So milligrams of glucose cancel out. Now I have grams of glucose. I am done with this conversion factor problem. So now all I need to do is multiply across the top, divide by the bottom, and when I do that, I get 5.353. 5.353. Let me double check to make sure I didn't make a mistake. Yeah, that's going to be milligrams of glucose. And let's check our sig figs here. So remember, when we're multiplying and dividing, the number of sig figs in our answer should be the same as the least number of sig figs in the measurements we are multiplying and dividing. So here we have 3 sig figs. Here we have an exact relationship, so that's going to be ignored. Here we have 3 sig figs. Here, pay attention to this. Here we have 3 sig figs because of the decimal point. So if that decimal point wasn't there, it would be 1 sig fig, but because of the decimal point, that measurement is 3 sig figs. And again, this is exact. So the least number of sig figs is 3. So that means that we can only keep 3. So we drop the 3 here. So get rid of that 3. And so now we have the proper answer in the proper number of sig figs. And that, ladies and gentlemen, is how you solve problems using conversion factors. I hope this was helpful. If it was helpful, if you enjoyed this video, then please, by all means, like the video, share the video, hit that like button somewhere down there. Nope, over here, somewhere over there. Also, make sure you subscribe to my channel, hit that notification bell. Make sure that when you do, you click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a problem or a question you need help with, or if you have a topic you would like me to cover, then please put that down below. I would love to do that for you. Thanks for joining me and have a great day.